Hi everyone, it's Mike from MintSpark, and today we're going to be looking at the Nezha Ocean Kit from Elecfrekas, which is being designed for the microbit. This kit includes the Nezha Pro block, motors, loads of cables, many sensors, input and output devices, and many building blocks for great examples to build. So for our little example, we're going to have a look at the website. Here is the Nezha Pro Ocean Kit on the Elecfrekas website. If you look on the side here, this will give you a link to the wiki page, which has all the instructions for all the kits that Elecfrekas sell. So for this one, if you look down, there is loads of general information, but they also have a large case library. So these are all great models that you can build and try out. And we're going to have a look at number 14, which is a simulated marine debris cleanup machine. That looks really great. So it's a little machine that can drive around and has some collecting mechanism at the front, which will simulate collecting the debris and hopefully make our oceans cleaner. If we look a bit further down, there are the full instructions that you can follow here. And this is what we're going to be having a look at just now. So we have our build complete. If we then go to the Microsoft Make Code page, we're ready to write our code for this model. So we'll start a new project. We call it Ocean. And then, as always, we need to load some extensions if we are working with microbit extension kits. So in this case, we can go to extensions and first of all, type in Nezha. And here you see you have two options. You have the old style Nezha block or the Nezha 2 or the Nezha Pro, which we're going to be using for this tutorial today. So if we click this, this will load all the blocks that we require for using the motors. And on top of that, for the Ocean Kit, we also need to load the Planet X extensions because all the sensors that are in there will require that. So for our distance sensor, for example, we need this Planet X extension here. Great, so that's everything ready. We're going to hide the simulated microbit here, so we've got a bit more space and maybe make this a bit smaller. Okay, so what we want to program with this is that it autonomously drives around. It sweeps in parts as it drives around, but if it meets an obstacle with a distance sensor, we want it to turn and go off in another direction. So that should be fairly easy. We don't need this on start block for this. So in this forever block, we want to achieve, first of all, that it moves, and then if it senses a distance, an object with the distance sensor ahead, it wants to turn a little bit and move off in another direction. So we need some logic blocks in here with some if statements. And the first one I want to look at is what happens if there is an obstacle in front. So we need to put a condition in here that describes something that's maybe closer than 20 centimeters to the distance sensor. So we need to go into the Planet X space section of our extension and go to sensors. And here we have all the sensors that the kit or the Planet X range includes. What we need is the distance sensor. So the value of the ultrasonic sensor, this is what we need to compare. And first of all, I'm going to change this to J4 because on our build, this is actually connected to port J4 on the Nezha Pro. That's quite important. And we'll leave centimeters as the distance here. So we need to compare it. Again, if we go into the logic blocks here, we can say that if I leave this out just for a moment, if I say that if the ultrasonic sensor that's connected to J4 in centimeters is smaller than 20 centimeters, then something should happen. And I will click this in here. And there's one thing I need to be aware of, that the ultrasonic sensor can actually show a 0 value even though things are very far away. So quite often if it goes into the distance and it can't actually measure anything, it will show a value of 0. So that is quite problematic, because if we just say smaller than 20 here and then put some turn instructions in here, what will happen is that if it senses far ahead and it's 0, it will start turning, although it doesn't actually need to turn. So to combat that, we need another logic block here. We'll put an AND block here. So we say, first of all, we need to compare if this distance sensor is smaller than 20. That's fair enough. But also, if we just copy what we have here, we need to check that the distance is actually larger than 0, because that guarantees us that we've got a valid distance sensing. Because if it's 0, we're not really sure what the value is. It could be actually quite far away from a wall, for example. So in this case, this first case, we know now we're near an obstacle. Now we want to turn. And with the Nezha Pro, there are various ways we can do this in our motor instructions. So if we come in here, we can pull out, for example, this very first block here. And we can say that one of the motors, which is at M1, for example, we want it to run at 30%. So it's not going too fast. And we want to run it clockwise, for example, for, let's say, 1 second. So we put 1 in here, and here you can see there's various instructions you can give the motors. You can turn it a certain amount of degrees, a certain amount of turns, and a certain amount of seconds. So we're going to put seconds in here, and we're going to duplicate this for the second motor, which is connected to M4. And also we want to run it at 30. And also we want to run it clockwise. And why is that? It's because if you look at the build, the motors are actually connected to the chassis in opposite ways. So if we want to achieve a turn, then we need to run one clockwise and the other one also clockwise. They will both turn in the same direction, but because they're mounted in different ways, it will actually mean that one of the wheels will go forward and the other one will go back. So this will actually achieve our turn. And there's one important other thing we need to discuss. If we open up these side panels here, you can see that you can actually choose what kind of delay you want. And there are two options here. So you have no delay and you have automatic delay. And for this, it means that if we have no delay, the instructions will jump straight to the next block and execute. So even though this motor will run for 1 second, the program will actually continue with the next block straight away. And the automatic delay means that the motor will actually run for 1 second and it will wait for that to complete before moving on to the next instruction. So because we want to have both motors turn at the same time, we need to have the first block with no delay, so they go straight to the second one, and then the second one we'll want to have with delay because we want to wait for the turn to finish before we move on to the next block. So this is our turn. So if the sensor is further away than 20 centimeters, we obviously don't want the turn, we just want it to go straight ahead. And for this, we can just use a drive block in here. So if we again go to this Nezha menu, and we have a block like this here, it says set the speed of motor M1 to a certain speed. So again, if we want to call this 30, and then we want to start the motor, and then similarly, if we duplicate this, and then we say for the motor that's on M4, we want to do the same thing. And as we discussed at the top here, we need to change one of those to -30. And again, why is that? That's because the motor is actually mounted in opposite directions on the chassis of the car. So if we want both wheels to turn forward, we need to turn one motor forward and the other one we need to turn back. And with these blocks, we don't actually specify how long the motor will turn. It'll just start turning until something else happens, which in our case will only be the distance sensor. If that detects an object, then it will turn. So this will be going on forever, going in circles, and hopefully avoiding all the obstacles. And maybe not necessary, but I also like to include a small, very short 100 millisecond pause in all these loops, just in case with some of the components, maybe not this one, it can actually lock up the program a little bit if it goes too fast and if it's polling the sensors too fast. So this is just a nice way to give the microbit a little bit of a breather to process other instructions should there be a bigger program. Good, let's download this and see how it works. With the optional joystick bit, we can also build a remote-controlled cleanup vehicle. So all in all, another great extension kit in the Nezha Pro range for the microbit from Elecfrekas, with loads of examples for you to build. It's got motors, it's got sensors, output devices, and loads of blocks. So plenty of fun and also very educational.